Hi, welcome back to Circuits with Angel. Today we'll be talking about relays and how they work. And then we'll be building a circuit in which we will demonstrate the mechanical function of a relay using a capacitor. Relays are very important components and can be found everywhere, literally everywhere. Relays are electromagnetic switches, which means when a relay is powered, an electromagnet gets powered and makes a connection on the inside of the relay, completing the circuit. And this can be heard when it latches. You take it for granted, but you hear it all the time. When you turn on a TV, you can hear it. When you turn on a blender, you can hear it. When you turn on a microwave oven, you can hear it. When you turn on a car, you can hear it. You hear it all the time. Relays, unlike transistors, which we will learn about in another video, can switch large amounts of voltage and current. But it cannot switch as fast as a transistor. And, as we saw, the relay can switch between different pins. It can switch to DC or AC current. Transistors are found in lower power devices that require less voltage and current, but switch on and off extremely fast, like an integrated circuit or a microprocessor. Relays, on the other hand, are found in household appliances, vehicles, machinery, and industrial applications. If capacitors are the heart of electrical circuits, and the brains are the transistors that make the microprocessors, then relays are the muscles that do the heavy lifting. Now let's get to building our circuit. First, we must put in the 470 ohm resistor to the negative rail, then the jumper wire from that rail to the next rail. And now let's put our relay one row below the jumper wire, making sure the notch is facing down. After that, we put in an LED. The wire's row is the negative leg, and the positive leg goes to the first pin of the relay. You can lift it up a bit to see the pins underneath if you want. Let's put in the second LED. The negative leg going to the jumper wire row, and the positive leg to the second leg of the relay. Remember, you can lift the relay to see the pins. Alright, now we are done with the LEDs and we can put in the jumper wires. First, we will take this jumper wire and connect it from pin 2 to a row on the space beneath pin 3. Next, we got a jumper wire that goes from the positive rail to pin 3. Let's put a push button between pin 4 and that jumper wire beneath pin 3. Next, we got a jumper wire that goes from the positive rail to pin 3. And the last jumper wire is a jumper wire that goes from the fourth pin of the right side of the relay to the negative rail. If you are wondering why a capacitor is there, it is to stop the relay from switching too fast. It only releases the charge after it fully charges up, which takes about half a second to a second to do. But before it gets the charge, there must be negative voltage in the fourth pin of the relay, and the jumper wire up here lets the negative voltage go to the fourth pin through the push button. And if your LEDs are going too fast, you can place this jumper wire with a 100 ohm resistor. Alright, here are our 3 points. 1. Relays are electromagnetic switches, and they are found everywhere in our daily lives. 2. We use DC low voltage and low current to activate a relay that can conduct high voltage and high current, either DC or AC. And 3. Relays can be dangerous if you don't use or handle them properly. Even Arduino relays can be dangerous. The pins on the back are live and will absolutely electrocute you if you're not careful in handling them. Always remember, safety first. Thanks for watching and see you next time.